Welcome to the Deep Dive. We're your shortcut to getting right up to speed on the most critical AI developments. We're looking at the last couple of weeks here, late September, early October 2025. Our goal today? Simple. Give you actionable insights. We'll synthesize the key tech breakthroughs, decode this huge financial arms race happening, and analyze the new rules being put in place. Basically, we want you to really grasp where AI is heading without getting totally swamped by information.
Yeah, and it's a fascinating moment, isn't it? Because you've got this real collision happening. On one hand, just unprecedented tech capability. I mean, we're talking models that simulate physics, advanced agents, writing code, stuff that was sci-fi just recently. And on the other hand, you crash right into global governance, serious legal fights, and frankly, just mind-boggling amounts of money concentrating in a few places. It's like the lab bench suddenly meets the courtroom and the corporate boardroom all at once.
Exactly. That collision is why we need to, dig into this. We've got this $500 billion fight for compute power that basically decides who builds the future. Then you've got models getting so real they blur the lines between creating something new and just copying reality. And finally, actual laws, enforceable ones, popping up to define who owns your digital self, your data. Let's get into it. Okay, let's start with this huge shift. If you thought AI was all just clever code, well, think again. The news this week really hammers home that the foundation now is physical stuff, concrete, silicon, high bandwidth memory chips. We're seeing investment on a scale that almost forces us to rethink what big tech even means.
It's the sheer scale, right? That's what feels different this time. Compute power, access to it, that's become the real bottleneck. And the infrastructure you need is so vast, so expensive, it basically raises the entry barrier incredibly high. Only a few players can really afford to compete at the frontier now. And that's the backdrop for OpenAI's Stargate project.
Stargate? Honestly, it sounds like something out of a movie, but the details paint a picture of something very real and just incredibly expensive. A $500 billion global network of supercomputing facilities. Why? Why $500 billion?
Because they're trying to lock down petaflop scale computing for future models. And a petaflop is a quadrillion calculations per second. You need that astronomical level of power to train the next generation systems, the ones that might actually show sparks of general intelligence. And securing that much power means this massive, coordinated global effort. You have to grab resources everywhere.
And it involves this incredibly complex international supply chain, doesn't it?
Precisely. You see Samsung and SK Hynix in South Korea, they're supplying essential high-bandwidth memory chips, HBM, and they're even co-building data centers. Then Oracle's providing 3 huge new data center sites in the US just to house all this gear. And SoftBank, they're leading the charge on the financing side. It's a global scramble for a piece of the action, for a piece of that physical pipeline.
Speaking of pipelines, this is where it gets really interesting, I think. Nvidia, who basically makes the chips everyone needs, is investing up to $100 billion directly into OpenAI. It's non-voting equity, but still, that's a supplier pouring a fortune into one customer. That feels unusual.
It's more than unusual. It's a fundamental shift in the economics here. And that funding isn't just cash. It's tied directly to a technical commitment. Nvidia has to deliver 10 gigawatts of high-performance computing systems, including, crucially, deploying at least 1 gigawatt of its next-gen platform by late 2026. So this isn't just buying chips. It's creating a dedicated, vertically integrated supply line. And that line is what lets OpenAI aim for models with trillions of parameters.
Trillions.
Yeah.
Just to give people a perspective, the biggest models right now are in the hundreds of billions. So this potentially gives OpenAI an almost unassailable lead in training power. But what does that level of vertical integration, a chip giant investing so heavily in one AI lab, mean for the rest of the market? Does it raise concerns?
Oh, absolutely. It immediately throws up red flags for antitrust scrutiny. When the dominant hardware supplier invests that much in one key customer, regulators have to ask, does this unfairly concentrate power? Does it distort the market for everyone else trying to buy those same chips? It really does echo historical cases. You think back to the DOJ looking at Microsoft in the 90s, right? Dominance in one layer of the tech stack leading to big legal challenges. Concentrated capital always attracts governance.
But is that antitrust risk maybe a bit overblown? I mean, AI development, chip making, it's all global now, unlike the PC software market back then.
That's a fair point. The global nature changes things. But here's the nuance. The sheer cost of something like Stargate, even if it's global, if it succeeds in locking down that much compute. It raises the capital needed so high that you effectively end up with maybe a three-horse race worldwide. Google, Meta, and this OpenAI Nvidia powerhouse. That kind of market consolidation, even globally, is exactly what worries regulators, especially now that national security interests are so tightly linked to AI leadership.
Okay, so if the infrastructure is the skeleton being built with all this money, let's talk about the brain, the actual AI models. We need to shift now to the cutting-edge systems being built on top of all that compute power.
And the models that dropped just recently, they really confirm capabilities are scaling along two key axes: realism and autonomy.
Yep.
Agency, you could say.
Right.
We're moving beyond just generating text or okay-looking images. We're seeing systems that genuinely try to simulate the world and others that can take complex, multi-step actions on their own.
Right. The prime example seems to be Sora 2 from OpenAI, their new video generator. It's not just that the video looks better, higher definition. It's simulating physical environments more accurately. They're using this term physics-aware. What does that mean practically?
That's the big qualitative leap, I think. Older video models often felt, well, a bit random. Things might float weirdly, gravity might fail, momentum looks wrong. Sora 2 seems to handle complex physical interactions much better. A basketball bounces like a basketball should. Shadows track correctly with the light source. Fluids slosh convincingly. It's like it's actually modeling the underlying rules of the world, not just mimicking pixels. And, importantly, it syncs audio and dialogue much more tightly with the visuals.
That realism sounds incredible for creative work, but it also comes with huge risks, doesn't it?
Yeah.
Especially with this Cameo identity tool they mentioned.
Absolutely. That tool lets you easily insert your own face, or the likeness of a licensed actor, into the videos Sora 2 generates. On one hand, yeah, it could democratize filmmaking, give tools to indie creators, but the deepfake potential is just staring us in the face. It's massive. To try and mitigate that, OpenAI says Sora 2 has built-in safety features like watermarks and C2PA metadata controls.
Okay, let's quickly define C2PA metadata. That sounds technical, but it feels important for people to understand.
Yeah, definitely. C2PA stands for Coalition for Content Provenance and Authenticity. Think of it like a digital birth certificate embedded in the file itself. It's an encrypted record showing where the content came from, if and how it was modified, which AI model generated it. Essentially, it's the main technical tool we have right now to try and trace a deepfake back to its origin, to prove if something is AI-generated or manipulated.
Got it. Crucial for trust and verification down the line. Okay, shifting gears from realistic video to autonomous action. Anthropic released Claude Sonnet 4.5, and their focus seems really targeted: software development, complex multi-agent tasks.
Exactly. Anthropic is betting on reliability, on making AI agents you can trust for complex jobs. Claude 4.5 apparently has much better long-term memory, and crucially, it can coordinate different subtasks effectively. That's key if you want an AI to actually write complex software autonomously. And the proof seems to be in the pudding, with this big jump in its score on the OS World benchmark.
Right, the OS World benchmark. What exactly does that test? And why is the score jump from 42.2% to 61.4% so significant?
OS World tests how well an AI can perform complex tasks by actually using operating system interfaces like a human would. Things like finding subtle bugs hidden across multiple code files, or setting up and deploying a whole software application from scratch. And that jumped from 42% to over 61%. Well, it's not just incremental. It suggests a move from an AI that constantly needs human oversight and correction to one that can potentially understand a whole code base, identify complex issues across files, and fix them largely on its own. Early feedback from places like GitHub and Netflix seems to back this up.
Wow, okay. That could really be a game changer for development teams. And the competition is just relentless, isn't it? OpenAI also pushed out GPT 4.5 for its pro users, claiming better knowledge recall, fewer hallucinations. And Meta's not standing still either, releasing Llama Pro, really pushing the open source angle for businesses wanting more control or lower costs. It feels like every major player is sprinting right now.
And all these incredible tech leaps fueled by all this capital we talked about, well, it's forcing governments worldwide to actually act. We're moving past just talking about principles, vague ethical guidelines. Now we're seeing actual enforceable laws being put in place, real guardrails.
And probably the most significant example, at least in the U.S. right now, is California. SB 53, the Transparent Frontier AI Act. Given California's role as a tech hub, whatever happens there tends to ripple outwards, becoming a sort of de facto standard for the country.
Precisely. Starting in 2026, this law specifically targets what it calls frontier models. And they define that quite technically. Any system trained using more than 125 floating point operations, or FLOPs. To put that number in perspective, 125 FLOPs. That basically targets only the absolute largest, most powerful models currently being trained. Think GPT-4 level or beyond. So the law is really aimed at the handful of companies building models big enough to pose potential systemic risks.
Okay, so if your model hits that FLOP threshold, what does SB 53 actually require you to do?
Several key things. You have to publish extensive documentation about the model. You need clear public policies on how you'll prevent misuse. You have to conduct and publish risk assessments. And critically, if there's a significant safety incident involving your model, you have to report it to the state attorney general within 45 days. It's really about forcing transparency and accountability onto the developers of the most powerful AI systems out there.
But the law also has this interesting countermove, doesn't it? Something called cow compute. How does that fit in?
Yeah, CalCompute is quite clever, actually. It's designed to be a publicly accessible computing cluster. The idea is to give researchers, academics, smaller startups access to the kind of high-powered computing they need to train significant AI models themselves. But here's the catch. They get access to this public compute resource in exchange for complying with the safety, transparency, and risk assessment rules laid out in SB 53. So it's a direct attempt by the state to push back against that concentration of compute power we discussed earlier, trying to democratize access a bit, but within these new safety rules.
That makes sense. And this desire for local control, for ensuring compliance with local rules, that's also driving this global trend toward sovereign AI, right?
Absolutely. A really clear example is the partnership between SAP, OpenAI, and Microsoft in Germany, specifically for the German public sector. Their whole goal is to create a sovereign AI cloud service. What that means is guaranteeing that all data processing stays within Germany, on German servers, fully compliant with strict German public sector regulations. No data leakage. It shows how even the big global tech giants now have to tailor their offerings to meet these strong national demands for digital sovereignty. It's part of Germany's push to get 10% of its GDP value from AI. By 2030, they want the benefits, but on their own terms.
And speaking of governments and trust, there was a big validation for the open source AI movement recently, too. Meta's Llama models got an official nod from the U.S. government.
Yes, this is actually a huge deal, particularly for government IT and procurement. The U.S. General Services Administration, the GSA, officially approved Meta's open-source Llama models for use across federal agencies. It's a major signal that open-source AI is now seen as a viable, secure, cost-effective, and compliant alternative for the public sector. It challenges the traditional dominance of proprietary closed models from vendors like, say, Oracle or IBM in government contracts. It shows governments are really starting to prioritize data control and avoiding vendor lock-in, alongside just raw capability.
So as these models get incredibly good at replicating reality, like Sora 2 making photorealistic video, we're seeing a real pushback from society, aren't we? A lot of resistance focused squarely on personal rights, on privacy, on who owns what in this new digital landscape.
Definitely. We're seeing lawsuits, union actions, challenges that go right to the heart of the business models for generative AI, particularly around the right to control your own likeness, your voice, and protecting human creative labor. The legal system is really starting to try and catch up with the tech's acceleration.
Yeah, one of the most visible fights is around these digital likenesses. SAG-AFTRA, the actors union, came out swinging against this AI-generated actress, Tilly Norwood, that a studio called Particle 6 introduced.
Right, and the union's argument is important. It's not just, oh, no, robots are taking our jobs. It's about the process. They argue that creating these digital actors by training AI on countless hours of real actors' performances, often without explicit consent for this kind of use, fundamentally undermines human creativity and their members' labor rights. And almost simultaneously, you had Bollywood superstars Abhishek Bachchan and Aishwarya Rai filing a lawsuit against Google, specifically targeting AI-generated videos on YouTube using their likenesses without permission. They're demanding stronger protections for personality rights globally. These cases are trying to draw the line. Who owns your face, your voice, in the age of AI?
But it's not just famous people's faces, is it? The legal and ethical questions extend right down to our everyday data and privacy.
Exactly. Look at Meta's recent announcement. Starting December 16th, They're going to use your interactions with their AI assistant, the chats you have with it, to personalize the content and ads you see across Facebook, Instagram, WhatsApp. Now, they say they'll exclude sensitive topics, but it's still a major shift. It raises immediate ethical flags about essentially turning your private conversations with an AI into ad targeting data. How much are we okay with our conversational data being commodified like that? It definitely pushes the boundaries of consent and privacy monetization.
And kind of underlying all of this, we can't forget that massive wave of copyright lawsuits that OpenAI, Anthropic, and others are already facing. Lawsuits about using copyrighted books, articles, code, images, pretty much everything to train these powerful models in the first place.
Yeah, those copyright cases are arguably the biggest legal wildcard hanging over the entire industry right now. How courts rule on whether training AI on copyrighted data constitutes fair use under copyright law. Well, the outcome could fundamentally reshape the economics of AI development. It could lead to massive new licensing costs for AI companies, or even force them to completely rethink how they gather training data and build their models. That's still very much up in the air. Hashtag tag conclusion and final takeaways.
Okay, so if we pull all this together, this week really highlights this duality, doesn't it? On one side, you got this incredible acceleration in technology, Sora 2 simulating reality, Stargate building the foundation for even bigger models. And on the other side, intense societal negotiation, new laws like SB 53 trying to set rules, lawsuits fighting over ownership of data and likeness. What's the key tension here that you think listeners should really grasp?
I think the core tension, the one that's going to define this next phase of AI, is this constant push and pull between concentration and democratization. You have forces like OpenAI and Nvidia building these incredibly centralized, powerful resources like Stargate, which could potentially lock out smaller players. That's concentration. But at the very same time, you have governments stepping in with things like cow compute, trying to provide public access. You have the open source movement gaining official validation, like with Llama in the US government. That's the push for democratization, this ongoing negotiation over who controls access, who sets the rules, who benefits. That's really the central drama right now.
Yeah, and that struggle over control impacts everyone, right? From the biggest tech companies down to individual users and creators. We covered a lot of ground today, but let's leave folks with one final thought to chew on, something that builds on that massive infrastructure push we started with.
Right. Think about the sheer energy demands needed for projects like Stargate. We mentioned Nvidia committing to deliver multiple gigawatts of computing systems. A gigawatt is roughly the output of a large power plant. We're talking small city levels of power consumption just for these AI data center networks, this immense ongoing energy requirement. It's going to force the environmental impact of AI right to the forefront. It won't be a secondary issue. It'll become a central, non-negotiable challenge for the entire industry. And that pressure, that unavoidable reality of the power bill and the carbon footprint is going to drive innovation in green computing and sustainable data center design much faster than maybe market forces alone would have. It's the next big infrastructure problem layered right on top of the technical ones.
An existential challenge tied directly to the cost of progress. Fascinating stuff. Well, thank you for joining us for this deep dive into the latest AI developments. We hope you feel up to speed.
And hey, if you're looking for more hands-on stuff like practical tutorials on how to actually use some of these technologies we talked about, agentic coding, prompt engineering, that kind of thing, definitely check out the YouTube channel. It's Ian Ochieng AI. That's Ochieng.
We'll catch you next time, fully equipped with everything you need to know. Thanks for listening.